Welcome student. This is Ruby laser system. So this is called Ruby laser because it consists of a pink ruby cylindrical rod, and it is also called the pulse laser because it produces a pulse laser beam. This is a three level Ruby laser system. So first of all, there is a ground state where the atom is present, which is struck by the incident photon by the optical pumping, and these atoms absorb this frequency h nu 02, which is equal to the energy gap between the E2 and E1. So when this h nu 02 energy is absorbed by the atom, then it is excited and jump from the ground state to the excited state. This is E2 is excited states. So this is called the stimulated absorption. There are three states required for the population inversion. One is ground state, another is metastable state, and third one is excited state. So population inversion means there are number of atoms are present in the metastable states is greater than the ground states, because the optical pumping xenon lamp is generally used for the optical pumping. So with the help of optical pumping, these electrons are jumps from the ground state to the excited state. So where the atoms are present only for the time required is 10 to the minus 8 second. This is the approximate time for the excited atoms are present on the excited states. After this time interval 10 to the minus 8 second, the atoms are jumped to the metastable state. The atoms are not resides for a longer time because it is in excited state, or atoms are also excited, so this jump to the metastable states. But in this case there is no emission, that means no emission of radiation, that means radiation less transition is occurs here. And after that metastable states, the state time, approximate time for the stay of atoms is approximately 10 to the power minus 3 second. So after this time interval is completed, then these photons are jumped to the ground state and emitting a frequency h nu 10, which is equal to this energy gap between the two labels E2 minus E1. So this nu 10 equal to E1 minus E2 upon h frequency is emitted. That is the frequency of this laser transition. Here the stimulated emissions is occurs. A stimulated emission means there are one photon is emitted, which is force emitted by the incident photon. Both the photons are identical and both are traveling in the same direction. This process is known as stimulated emission. And in case of spontaneous emission, here spontaneous emission is occurs between the excited state and metastable state. So spontaneous emissions means sudden or instant. So in this case there is no any radiations, means the photons emitted which is absorbed by this atomic chain. So the continuous intensity of laser beam is emitting. For this a constant optical pumping is required. So the rate of emission of constant intensity of light, because which is fulfilled by the xenon lamp as a optical pumping, and number of photons is not less than in metastable states than the ground states. then the population inversion occurs, which initiates the spontaneous emissions, and finally we get the constant laser beam. Thank you very much.